the end. So this is the last part of section 4-5. Tomorrow we're going to plan on kind of an in-class worksheet over 4-5, so you won't have any homework over spring break. But there is one more little thing we have to do with U substitution. And so I kind of gave this a new name here because this is kind of a new topic. It's called U substitution with a change of variable. And there's going to be a few things to write down first about this before we try any. And so these are basically some steps that we follow to do U substitution with a change of variable. It says, still choose a part of the integrand to call U. Still choose a part of the integrand to call U as before. And when I say as before, I'm kind of referring back to how we always let it equal the part in the parentheses or under a radical. That part is still the same with the change of variable. But then here comes sort of the new part. It says if the integrand still contains a factor of x, if the integrand still contains a factor of x after doing the U substitution, then solve the U equation for x. Got a lot of variables going on up here. Solve the U equation for x and substitute. If the integrand still contains a factor of x after doing the U substitution, solve the U equation for x and substitute. Like most things in math, I give this to you, it probably doesn't make a whole lot of sense right now. It'll become more clear once we see this happen with the examples. Now, all of the ones that we're going to do with the change of variable are going to be indefinite integrals. So you won't have an A and a B to plug in later on. So it just says find the indefinite integral. And I think we're just going to try 3 of them today. So, first one, and again it starts out the same way. The integrand here is x times the square root of x plus 1 dx. In my opinion, that is not very rewritable. I guess I could go ahead and change that square root to be a 1/2 power, but even after doing that, there's no way to rewrite that. You're tempted maybe to distribute that x, but you can't distribute because that quantity is to the 1/2 power. So again, it's not very rewritable, which tells me I probably need to try U substitution. Just like earlier, U is going to be what's under a radical or in parentheses. And so for us, that's just going to be x plus 1. Now, du, if u is x plus 1, du is technically just a 1 dx, or you can, I guess, just put dx there. That's all you have for du. So look at what you have over here versus what you have over here. I know that part is u, so here in a minute, hopefully that'll become u to the 1/2 power. But this is the problem. The only thing you're supposed to have in this integrand, the rest of it, is only supposed to be 1 dx. We have x dx. And so this is where it was talking about earlier, where it said if the integrand still contains a factor of x after you do the u substitution, then you need to take the u equation and solve it for x. So if I need to solve this equation for x, I'm just going to subtract 1, and x ends up being u minus 1. Now, the next part of the step said, then substitute. So watch what we're going to do here. We're going to take u minus 1, and we're going to plug it in right here for x, because it's saying over here that x equals u minus 1. So I take my integral. Instead of x, I'm plugging in u minus 1, and I'll go ahead and replace that part, the underlined part in blue. I'll replace that with u, and the rest of that now is just that part, but the rest of that is du. So again, we did our u, we found du, but the integrand still contained a factor of x. We didn't want x dx, we just wanted 1 dx. That, anytime you run into something like that, that's when you have to know that it's going to require a change of variable. So solve the u equation for x, plug that in. Now I still can't integrate right now, but at least now I can simplify this. I can take u to the 1/2 power, and I can distribute it into this quantity. I couldn't distribute up here because the quantity was to the 1/2 power. It's not to the 1/2 power anymore. It's just technically to the first power. So when I take u to the 1/2 times u, I'm multiplying with the same base, so I have to add my exponents. And so you may want to think of this as u to the first power, or better yet, since this has a denominator of 2, you might want to think of it as u to the 2/2 power. So after I add those exponents, it becomes u to the 3/2. I'm not integrating right now. This is just getting the integrand to the point where it can be integrated. Now, second part, u to the 1/2 times 1, that is just u to the 1/2. So I'm going to integrate that stuff now with respect to u. Okie doke. So let me go ahead and do that while I'm on my way. If I add 1 to my power, that would be like adding 2/2. So I'll make that u to the 5/2 power all over 5/2 minus, second part here, add 1 to that, it'd be like another 2/2 that I'm adding. So that becomes u to the 3/2 over 3/2. I'll go ahead and put plus c there, but I'm not quite done. There's a couple more things that I would do to this. First of all, the fractions on bottom can come to the top if you flip them. So this is now 2/5 u to the 5/2 power, but I'll go ahead and put what u is back into this. So it's actually x plus 1 to the 5/2 power minus, flip this fraction over, it becomes 2/3 u to the 3/2 power, but u was x plus 1. So there's that, and then don't forget always, got to put our plus c. So that would be our answer for example 1. Okie doke. Any questions about how we got that one? Thinking ahead, go ahead.
So like when on the one where it says u 3 to the second minus u 1 to the second, how come you couldn't just subtract those right there?
Oh, let's see here. U to the first power. Yeah, good question. I would say, you could. Now, let me think about that for a little bit because
Your answer would be different.
It would be.
it would be different. So there has to be a good reason why we can't do that. I see what you're saying. Most of the time, if we have the same base, we usually can. Okay, no, I got the idea. I got it. All right, here's my answer. Had to think about that for a minute. But the reason we couldn't do that is because they have different exponents. Let's go back to something a little bit easier, like back to algebra here. If we had the same base, so like just an x, but different powers, so like a cubed here and a squared right there, we wouldn't really be able to subtract those and just make it x to the first power. The only time you could subtract your exponents like that is if you were dividing. That would turn it into x. So I guess the main answer would be that these are not technically like terms since they have different exponents. Yeah, very good question. Anybody else? Good stuff. All right, let's try a couple more here. Example 2. And when you get to something like this on a test or a quiz, I mean, it's not going to say in the directions that it's going to be a change of variable. It's one of those things you have to just kind of pick up on and notice. So as I look at this integrand, x plus 2 times the square root of 1 minus x, I could rewrite the square root as 1 minus x to the 1/2 power, but even doing that, I can't really simplify this. These are not allowed to be FOILed since that quantity is to the 1/2 power. So my brain is telling me that I probably need U substitution. Now there are 2 quantities up here that you could choose from. I mean, this is in parentheses, that's under a radical. Which one do I go with? I would say most of the time the radical kind of trumps the parentheses. If you've got something under a radical, I would maybe at least try to make that U and then see what happens from there. If I go that route on this problem, then du is just going to be negative 1 dx. And so I start to match everything up. I know that is u. So eventually I'll turn into u to the 1/2 power. But then I need all of that for du. So I have the dx. And before I worry about this extra factor of x, that's the key right there. If you have an extra factor of x, you're going to have to solve that equation for x and then do the change of variable. But I am noticing something else over here that I need in my integrand. So I'm going to fix that part right now while I'm thinking about it. I'm supposed to have a negative 1 dx, and I didn't have the negative 1. So I'll go ahead and put that down before I forget to do that. Now, extra factor of x. You're not supposed to have this here. So to help us out, we're going to do a change of variable. I'm going to solve this equation for x. So think about solving that for x. You could add x and then subtract u if you wanted. So that's actually going to turn into 1 minus u. Now the difference between example 1 and example 2 is that it's not just x right here, it's x plus 2. So you can handle that however you want to, but I kind of like to just go back to this equation, and if I need x plus 2 instead of just x, then why don't I just add 2 to both sides of that equation? I'm keeping everything equal since I'm doing it to both sides. And so that x plus 2 actually ends up being 3 minus u. Once I take the 1 plus 2 right there, I get 3 minus u. So instead of x plus 2, I'm going to replace it with 3 minus u. Now don't forget about the negative 1 out front, but then here we go. It's no longer x plus 2. Now it's 3 minus u times, this was u to the 1/2 power, and then all the rest of that stuff in green was du. Now this is going to end up being kind of like the last one where we have to distribute. Any questions about how we got up until this point? All right, so distributing, I'll leave the negative 1 where it's at, and then 3 times u to the 1/2, that's just going to be 3u to the 1/2, minus, this is kind of what we had last time, if this is u to the 2/2, 2/2 plus 1/2, that would be 3/2. And then I can integrate that all with respect to u. So I keep the negative 1 out front. Now, it's up to you what you want to do with the negative 1. I may just put it in brackets here for a little bit, or put it on the outside of our brackets. Now, for this part, leave the 3 out front, add 1 to your power. That would now be 3/2, and put your new power on bottom, minus, coming back to the second part, add 1 to my power here, that is a 5/2, all over 5/2. I'll end my brackets there, I guess, and then put the plus c down. So what to do with the negative? I mean, you can just distribute the negative back into all of that. That's probably what I'm going to do here in my next step. But think about what's going to happen right here. This flips over and becomes 2/3. So 3 times 2/3, the 3's drop out and you just get negative 2 u to the 3/2 power. And I'm going to go ahead and put back in what u equals. Then, putting the minus to this part, I will have the 3 here. Probably I should have put my parentheses there. The 3 is not really with this second part. The 2 minuses make a plus. And then flipping that fraction over, I'll get 2/5 u to the 5/2, again, u was 1 minus x, and then finally I can put plus c. So again, the negative 1 doesn't just go with the first term, we kind of had to distribute that to both. Okie doke. X plus 2 instead of x. Find what x is and then just add 2. Any questions about that one? Weird here, slightly different than yesterday. Now, let's go ahead and do just one more. This is example 3. And it says that we are integrating x squared over the square root of x plus 2 dx. as far as rewriting the integral, only thing you could really do is move the square root to the top and maybe turn that into x plus 2 to the negative 1/2 power dx. But even then, I can't rewrite it any further. I'm not allowed to distribute the x squared, so I'm thinking we need some more u substitution. And here we go. U is typically what is in parentheses or under a radical, so either one. And then du in this case is just 1 dx. I see the u, and all I need for du is 1 dx. I have the dx, but I also have this extra x. And actually, in this case, it's not just x, it's x squared. So I'm still going to take that equation and I'm still going to solve it for x. Now, to get x by itself, you'll subtract 2. So it says x equals u minus 2. All right, that's great, but I don't just want x, I want x squared. And so I'll kind of do what I did on the last problem. Let me take this equation and turn it into what I need. I don't want just x, I want x squared. And so if you square both sides of that equation, you're going to end up doing some foiling to simplify the u minus 2 squared. We're going to have to FOIL that out and see what it equals. U times u is u squared. For the outer and the inner, those combine to make a negative 4u. And the last terms turn into a plus 4. So this quantity is what I plug in right here for x squared. Got a lot of colors up here, but now it says, instead of x squared, it says u squared minus 4u plus 4. That is x squared. Now, outside of that, I'm going to have u to the negative 1/2 power, and dx, that's the only thing that's making up the du part for us. Technically, it was 1 dx. Now, again, this is a very common step with the change of variable. Once you rewrite it with all of the u's, most of the time you are going to have some kind of distributing before you get it to the point where you can integrate. All right, now I'm distributing u to the negative 1/2. So this is u squared. And if you want to think of that 2 as a 4/2, when I multiply with the same base, I add my exponents. Well, 4/2 plus negative 1/2, that's just like taking 4/2 minus 1/2, which is 3/2. And again, this has not been integrated yet. This is just distributing. All right, take it times the second part. The negative 4 can stay in the front. And this is technically u to the first, or we could do 2/2 there. So 2/2 minus 1/2, that is just a positive 1/2, or 1/2. And this part's the easiest one. Take a 4 times u to the negative 1/2, and it's just 4u to the negative 1/2. All right, now I can integrate. I'm going to add 1 to my power, so that is now u to the 5/2 over 5/2. minus 4 times, this is going to be u to the 3 halves over 3 halves. Got a lot of fractions on these. And this is plus 4 times u to the 1/2 over 1/2. Negative 1/2 plus 1 is positive 1/2. Now let's flip all of this over and put back in what u was. I'm running out of room. So the fraction on bottom flips. I'll try to squeeze this in. This is now 2/5 u to the 5/2 power. Okay, so 2/5 times x plus 2 to the 5/2 power. When I flip this fraction over, negative 4 times 2/3 is going to be like a negative 8/3. So that didn't work out real nice, but I can leave it like that, times u to the 3/2 power. And last part, if you flip the 1/2 over, it's a 2. 2 times 4 is 8. So now that is 8 times x plus 2 to the 1/2 power plus c. That all the way at the bottom there, that would be our answer for number 3. Change of variable. Anytime the integrand still has an x. Any questions about number 3? All right. So the assignment, I think, has 4 problems in it. This is C86 from page 342. We're going to do 63, 65, 66, and 68.